Hello and welcome to the first episode of Xelectrics. Here we have a hameg hm203-4 oscilloscope, which is rated for 20 MHz, displaying this signal. Now this is a signal, it's not a generated pattern. What we have here is the two probes connected to the oscilloscope, probing itself, probing its own sweep speed. Now one sweep speed, one of them is significantly larger than the other. Let's see here. One is set to 50 millivolts per division. It's the first channel. And the second one is set for half a volt per division. That's around 10 times bigger for this one than for this one. Essentially what I'm trying to do here is I was just trying to find where the sweep signal is, and I have, so I could do the mod for the rear panel. Now here we have two BNCs I'll use for this, just salvaged from a Senyo monitor. And here we have the rest of my laboratory. Not the best shot, but still. Now this is my first scope, but I haven't had it for long. I ordered it on eBay from Belfast, and there are some problems with it. Originally, the little calibration tab here was broken off, and I just had to open the thing up, take that out, and put in a little hook there. And another thing is the component tester. Turn that on and that shows up. No matter what, say if I, well, I'm not going to do that now, but if I was to mess with the controls for that, it wouldn't change a thing. Now here's another thing, the times 5, it zooms in, if you let go of it, it zooms back out. Now this scope is flawed, but it was pretty cheap. It's got its external triggering here, time base, everything you really need. Now how I'm doing this with the same sweep signal, that's another problem, the button. Damn it. Got rid of the button. Just put that back in there. Anyway, I'm doing it with the same signal, which is there. Well, not the same signal, but two different signals, both of which are derived from the same one. I'm inverting one, moving it there. So instead of, for channel 1, it's ramping up, but it's inverted, so it's ramping down on the screen. Channel 2 is ramping up. Channel 2 is the amplified one, I believe, yep. That is connected to the terminal of the switch, which is the horizontal external switch, or the XY mode. And the other one is this probe, which is set directly onto the pin, the resistor network of the sweep generator. And time base, I'm just set it to the most stable one here. And see these dots here? These dots are generated from the shot mode. If I was to turn that switch off, straight lines. Now you can tell that this is what I'm saying it is, because as you can see, where it's the brightest the brightest spot is on top of the darkest spot on the other waveform. So it's switching back and forth at a rate of around 100 MHz. So for higher frequencies, you'd rather have alternate mode, which alternates them one beam, and the next beam, then one beam, and the next beam. Chop mode just sends one beam across, and shorts between the signals, since it'll be fine for a signal not that high a frequency, but for choke mode, let's do that. Alt mode for that. Oh, that's the wrong button. Set this back to where it's meant to be. There we are, close enough. Now, by tomorrow I should have the panel done, the part of the real panel done, because for now it doesn't actually fit properly. It wiggles around in there. I'm not sure, because I also have to find the Z signal, which is that one there, which essentially controls the contrast or the brightness of the screen when pulled low or high, depending on how it is. Now I've already found that signal. If I take this probe down and hook it onto this resistor here, whereas I can't try getting shot, that one there, the one in the center of the frame. There we are. Let me hook that on. That's about as good as I'm going to get it. But as you can see here, there's a bit of ringing at the end. And the reason you can't see the signal itself is because every time that goes high or low, every time that goes high, the trace actually turns off, so you won't ever be able to see that go high. Unless you have another oscilloscope to probe this with, which I do not. Now here we have this chip here, which is what controls the actual Z pattern. On the back we also have the connector for the space for a connector for the Y channel, which is essentially the up and down, which is already on this one.